Okay, welcome to another talk, and this time a soon-to-be colleague of mine, McCallum. Yeah, I don't know if you will explain that, but
yeah, okay.
Yeah,
can you hear me through here? I've got a thing. Yeah.
Yes, so he will talk. This is really future-related, at least the title. How future technology will affect game technology, and. Yeah, be aware of his Norwegian accent. Oh, no, he can explain everything. Okay.
Hey, okay, so most of you know me. I've been in Norway for a while, and I've been working in Gjøvik. But as of January, the decision was made that yeah, so we're merging with NTNU. So our new undergraduate degree will actually be an NTNU undergraduate degree. So yes. Oh, am I on mute? Yes. Okay. I'm probably loud enough. Ooh. Okay. So now I have to talk really softly. Are we being recorded? Okay. Then it makes sense to just keep speaking in the microphone. Okay, so we're merging with NTNU, and so I will be at NTNU and be able to kind of use some of their resources and some of their staff, and Alfinger and I will have to work together in various projects, which will be fun. Now, I gave a talk at JoinGame a couple of years ago on future technologies. Since then, I actually did an update of that for the Spill conference, the Spill conference, and this time I thought, and so I kind of done the process of updating, but I've also added some more stuff on game development process rather than just consumers technologies. So, systems, right? So we talk about systems, and yeah, I mean, we've got all of the PlayStation 4s, Xbox Ones, and Steam boxes, where there was like at GDC this year, they're pushing like a Steam box, it's going to be great, and they're all pushing that. And as a developer, yes, you should understand all of the potential console outputs as well as PC. One of the interesting areas was looking at the Raspberry Pi, and as you were saying, the variety of these small low-cost devices. If you actually look at the raw power of Pi 2, it's about half the power of PlayStation 3. Right? About 10 times the power of PlayStation 2 on this $35 tiny little device that could be anywhere. Right? So, as a developer, if you're thinking, okay, we're going to make something and it's going to be released in a year or so, we can have high quality graphics, high response rates pretty much anywhere, right? Because we can put these devices in your car, in your TV, in each of the chairs along here, right? $35 isn't a massive amount of cost. And so, in the back of every airplane chair, there could be a Raspberry Pi running your display. So instead of having those shitty airplane games, have you ever tried playing the games? Oh God, they're all. But for $35, they could have a full, basically PlayStation 2 level at least sitting there, available to play. Right? And that's now cheap enough to start happening. So you can start looking at how you create those embedded experiences at high quality rather than low quality. I looked at input again, and the wearables, I've now got the next version, so this is the Basis Peak. How many of you have got a Fitbit or a wearable on you? 1, 2, 3, yeah, and they're coming. Making games out of them, I know I've got this games around my watch. It's a different approach, but there's more of these. So we've got all the gesture inputs. We have the BCI stuff, right? So I've tried to make games with this, and I've had students make games with BCI. Yeah, it's really hard making games with using EEG, right? And as a game developer, I probably still wouldn't try and make a game out of this, right? You've got this Neurogaming conference and stuff, but still, not sure I'd try and make games because one, the infrastructure, the number of people who have these devices isn't really large enough. And everybody's experience of them is different, right? Because they're kind of a biofeedback mechanism. And as you said, the Control VR, the fast Kinect mapping solution, where you take the Kinect and it just maps the Kinect skeleton to whatever input you want it to be on a device, right? And you look at GlovePi and FreePi, these ideas of how do I remap input devices to control games? Now, some of this is, and like perhaps the most active area of development in this is around disabilities, right? Because there's a bunch of research money going into how do we become more inclusive. And one way of doing that is, you make these interfaces from people using weird devices to controlling a game. Now, what that means to you as a developer is that people will be using odd devices as an input device, right? The Control VR will be an odd device, right? They'll have their arms moving. But, they might be using the Omni, they might be having an EEG device, they might be having some, like the Razer Hydro. The devices can no longer be used as part of your play mechanic, right? And I remember, and so this is going way back, right? There were some games where you would use your joystick and you'd have to pull the trigger to shoot, right? And then, the joystick manufacturers came out with like an auto button that you could flip on your joystick and it would just fire as quick as possible, right? And in some games that meant you won instantly because there was no way they could pull the trigger faster than you could have switched the auto function on and have it fire every possible bullet. Now, when you design a game and you look at your interface and you use that as part of the friction, right? Part of the challenge of the game is mastering the interface. Somebody comes in on a side channel, creates a new interface, maps that new interface to your game, suddenly what was part of a kind of challenge mechanic you'd created, or a friction you'd created to make the game challenging, it goes away, right? And you see this with even the Wii mode, right? With the Mario Kart steering wheel, right? You can actually control the steering wheel still with the D-pad, and people playing with the D-pad are still much better than people playing with the steering wheel, right? Because with the D-pad you could go full lock much faster. And so it actually had a different mode, and it would record which mode you were in to give you different scores, because they couldn't use that interface as part of the play mechanic. So as a developer, we have to think, okay, in the future, people will plug whatever interface they like into our game, and it will be doing this auto mapping thing, and creating this interface which isn't the one we're in control of. Output devices. So the VR stuff. Now, is that me being, am I tickling things? I just don't like the bang. The VR stuff. Now, Ulla just talked a bit about the VR stuff. One of the things he didn't mention, which I, as a lecturer, and at the moment I'm presenting, you guys are nicely static. I'm in control of what you see, right? So, because you're there, I'm here, I'm presenting that way. Now, one of the things I try and do occasionally is create a semicircular lecture theatre, right? So where I have students sitting on both sides of me, and I stand in the middle and lecture to there and to there, as well as in front of me. Now, there's an area of theatre called theatre in the round, right? Which normally in a theatrical production like we are here, I'm here, I present to you, right? And this is the same with film, right? They have the viewer's perspective, and you make all these tricks to get the viewer's perspective right. In theatre, you do the same thing. In theatre in the round, your audience is there, 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 and there. You are completely surrounded by the audience, and you are in the pit in the middle. And you act your scene in every direction, right? And that's the kind of mental shift you need to do to start thinking about how do we make games for VR, because you are no longer in control of the audience's perspective, right? And so it's that mental shift. How does that shift affect my process as a developer? What do I have to think about when I make that massive shift? Ray tracing, and I'll get back to this in terms of development, but ray tracing has a similar effect on those tricks that Andreas was talking about, you talk about getting close to the mesh, right? If you're doing ray tracing and you're using solid objects, right, constructed solid geometry, then you can get as close as you like to the mesh, because there is no mesh. It's just a mathematical function that describes the surface of the object. Right? And so you can get as close to that stuff as you like, and the ray tracing will still work. But all your tricks on how to do lighting and texturing and how to make your mesh look nice, out the window. Right? All of that process changes. And as we move to real-time ray tracing, and we're nearly there, right? I mean, it is starting to be possible to run real-time ray tracing. Not at 4K, right? 4K is a problem. But, you know, for HD and 30 frames a second, yeah, we're starting to get there. And the new graphics cards are allowing that. This change in your process is going to be enormous. Augmented reality. It's one of those new technologies that, like you were saying, you guys bought a whole bunch of the BT200s. I've got upstairs the Meta space glasses. Any of you heard of the Meta space glasses? Interestingly, Meta, who are making the space glasses, to do their UI, what they did is they looked at Iron Man, the movie, found the guy who designed the graphics for Iron Man, and they hired him as their UI director. Right? So they actually explicitly hired the guy from Iron Man to try and make the UI for their AR glasses. Right? And that was their approach to make it look cool, was to go and hire a movie guy. And it's see-through augmented reality. Again, this creates some really interesting challenges as a developer, because you're no longer kind of saying, okay, I'm in control of the world, right? This is my world, my virtual world, right? You will play within my rules and from my perspective, right? I will give you the perspective and I will tell you what's there. In AR, you know, I'm looking through stuff. And if I decide to move over here, then the background changes. How do I do appropriate text? If I'm going to have like text on screen, if it's against a white background, I can't use white text. But then suddenly you rotate and it's our black background, so I can't use black text. How do I adapt my display to the random stuff that the guy's seeing through? How do I accommodate for some of those unusual situations? And this is the problem with Google Glass and why it's kind of moved into their, we're not sure we're ever going to release a product of this category. They're going to move out of their yay new to category in Google. Is that just like when they first brought out context-based ads. I don't know if like Google gives you contextual ads. So you're looking at something and it'll give you an ad related to the thing you're currently looking at, right? The context. When they first did that, there was a bit of controversy because they did things like had a story about a 3-year-old girl who was killed. And then like the ad was for funeral services. Right? And there's something about sensitivity, like, you know, when you're reading a story about funeral, get your coffins here. It's kind of, that's, you know, all sizes. Automated contextual information doesn't always work. If you're making a game in AR, you expect your player to look through your content at something, right? And you're no longer in control of that thing. That's a harder design process, right? How do you make sure that your game's context is the correct one for what they're looking at? How do you arrange your content in that context, right? Do you use markers? Do you use image targets? Like, just the mechanics of it is one thing, but making sure that it fits in the world they're in, that's another challenge. So, AR is a challenge. Smart objects. Now this you could describe my watch as now a smart object, right? Because it's got lots of tech in it. But we are getting more and more smart objects. And certainly when I buy my kids toys, they're more and more kind of technologically advanced. And even like, you know, you buy them in like for throwaway money and they're like radio controlled and they're kind of, you know, they've got lights and they respond and it's kind of, wow, so much tech and so cheap. we're getting at the point where you've got a lot of these smart objects. You've got 3D printing. And for smart objects, we as game developers can do interesting things with those smart objects. Right? And when we talk about, for developers, when you're thinking about your game, traditionally you've kind of made a game for computer, for example. But the Nintendo certainly gave us the Wiimote, and they, massive risk. Everyone told them it was going to fail completely, right? Nobody will play with a stupid peripheral, right? And the Wii worked really well. Now, these smart devices, a lot of them are coming around, like the smart toothbrushes and smart shoes and smart clothing. It's cheap enough to put all that technology into stuff now. How do we as developers either add value to that, right? Can I find a way of designing a game around this piece of tech that now exists? How do I make something interesting, add value to that company, and make sure that company pay me to do that, right? Or I get some percentage of their sales because I make their product better. Right? Or can I make a game that does require, there's a toy that has this playful, physical toy. Because in a world of digital distribution, you said, you know, great opportunities in digital distribution. But one of the challenges is the kind of nothingness of the thing you buy, right? You buy kind of access to the thing, you don't get anything. There's no tangible thing you hold on to. And people are often willing to pay more for something they can hold than something that is just on the computer. Right? And so if you can create a device, if you can have a unique value proposition or a unique selling point, your upsell, what is it that you can sell that is a smart device? Can you see your game having a device associated with it rather than just being on screen? Does that create new opportunities? Because this idea of fast follow versus kind of already used terrain. Now, it may be that when you first see something, like at the moment they're saying MOBAs, right? The massively, the multiplayer online battle arenas, right? Lots of them at the moment. You try and make one of those, you're probably not going to break in, right? Because there's already a lot of really good games in that genre. Right? But there are other genres which there aren't a lot of good games in. So just following what's currently popular isn't necessarily going to get you the highest return. And so being able to identify, okay, maybe it's this gadget, maybe it's this thing. What has the potential? What's expanding? What's making a market that I can make my game within? Processing. Processing power has continued to evolve. Like every year these mobile phones become more and more powerful. As that decision around like that sort of Unity ports to mobile, well, you know, they all kind of now do, right? So that the Unity advantage of that is gone. But also the power, the performance difference between your cell phone and your netbook is kind of shrinking really fast, right? The GPUs they have on mobile phones and the multi-core and the amount of RAM they have, the performance, you don't actually, you can stop thinking about performance as being your main differentiator. It's now things like touch, right? That the person will put their hand up on the screen. But you know, my machine's touch screen, so that's not actually different either. Right? Windows 10. What is that new holographic interface they're doing? Right? Windows 10 natively supports holographic interface. Windows 10 natively runs on the Raspberry Pi. Right? So the Raspberry Pi will have Windows 10 and there'll be a holographic interface, whatever that means, right? But it's going to have this kind of AR, new technology, and the power isn't going to, well, the performance power isn't going to be the issue. With mobiles, it's battery power, right? It's how much energy you have to spend. And that becomes an interesting proposition. How do you still create value? How do you make some game run for a long time and not use up too much power? GPUs, yeah, this was the slide from a while ago, but you know, it's just massive amounts of power on GPUs. And I saw at GDC that NVIDIA and Alienware have their external case that they say, well, you know, the Alienware computers, yeah, they've got a mobile 980 in them, but, you know, it's not quite good enough. So what you do is you buy the case and you put in 980 Ti SLI into your case beside your laptop. So when you're gaming at home, you have this enormous graphics hardware sitting there running your 4K screen, and then when you game on the train, you have your normal laptop with its small screen. Right? So GPUs and that enormous power is why we're linking back and looking at ray tracing. And the problem with ray tracing is that it completely changes your process as developers. Parallel hardware, the Raspberry Pi is 4-core, right? 900 megahertz. My phone is 4-core. It's hard to buy a laptop that is a single-core machine. Have you even bought a laptop that's a single-core machine recently? No, right? Dual-core is, if you work hard, you can find a dual-core machine, right? But usually now it's 4 or 8, right? That creates different ways of thinking, right? We were used to thinking in a very linear development way, right? We have a game, it's running on the CPU, it's doing its thing. But with multi-core, you actually start having to think, okay, the graphics is running independently of the world, which is running independently of the networking. How do I keep all of those different independent activities going together? Right? How do I manage all of that? Now, one answer is do you need to use all that power? Now, if you pick a game engine, you say, oh, whew, no, I don't care about that. I'll let my game engine handle all of that. I'll just do the script. Right? Perfectly reasonable answer. If you want to push and you want to differentiate yourself and you want to be different around the tech, then you worry about the power. And you worry about what tools will utilize that. So if you're looking at a game engine and you want to use ray tracing, you do the whole, well, you know, what game engines are there available, which ones produce a ray trace beautiful output, which work with my workflow. Right? And I think you're right about workflow in Unity. Right? The reason why it was so popular is that its workflow was easier than Unreal, right? Which was just sometimes horrendous, or Cork was horrendous. The game engines were designed by people who weren't thinking about other developers. They were thinking what they needed. So they developed what they needed and then just exposed that to other people. And yeah, that's not necessarily the best process for designing a usable system. I actually spend a lot of my time when I'm teaching programming around how to communicate your ideas as a programmer. Right? So I don't actually, I'm not so worried about like which for loop or while loop or like how you use quicksort or like implementing quicksort. It's about how you communicate as a programmer with other programmers in your team, and how you communicate with your artists, and how you communicate with your scripters, and how you communicate with your AI people. How you communicate is more important than the specific tech you use. So for all of this, all of that power, one of the side effects of it means that you don't need to be too optimized and clever. Right? I see far too many programmers doing clever things, right? They try and optimize early, because optimization is like a lot of fun to do. But they sacrifice their ability to communicate what they're developing to other people. And they optimize early, right? They say, oh, I know a better way of doing this. And they haven't even worked out if it's too slow already, right? Because, yeah, you could spend 5 or 6 days cutting down your load time from 3 seconds to 2.8 seconds. Right? And those 0.8 of a second load time, when the person starts the game, you're willing to put 5 days of work into it. What's the point? Right? It only happens once. And I actually, when we're working commercially, you pop up your logo for at least 3 seconds. Right? Because what we found, and I saw some research on this, if people click to play a new game and it immediately starts, they didn't value it as much. Right? Because obviously it was very small, because it started immediately. Right? Actually putting in the friction on the loading screen. Right? To say, no, you're going to have to wait for this. You know, for 3 seconds, but you're going to have to wait, because I've got a lot of content in this game, honestly. Right? That increased people's perception of your value, even though it didn't actually increase the amount of work you're doing. So, sometimes you're optimizing things that actually you don't need to optimize, because you're going to use the fact that it takes a bit longer. I saw an interesting analogy in the real world. One of the American airports was having a lot of complaints about how slow it was to get their bags from the plane to the carousel. Right? So people would get off the plane, they'd walk through the airport, and they'd get to the carousel, and then they'd have to wait for about 8 minutes for their bags to show up. Right? People saying, oh, this is terrible, and you need to improve the speed, and you know, lots of negative comments. And so the airport designer decided that, okay, to solve this problem, we'll make them walk for an extra 400 meters. Right? It'll take them about 2 to 3 minutes longer to get to the carousel. All the complaints disappeared. Right? Because in their mind, you know, the plane is now further away from the carousel. They went from waiting times of 8 minutes down to 6 minutes, but it was 6 minutes and it was a lot further to go, so you know, that's not so bad. And that kind of clever changing the way you do things, rather than necessarily trying to optimize a process that is already as optimal as it can be, might be the better design decision. Right? So as a game developer, you have to kind of think, okay, there's this function which is behaving a bit slowly. How can I like move it to somewhere else? How can I do it beforehand? How can I treat that as a feature of my game, right? How do I design around constraints? Because those constraints, some of them, aren't really your job to fix. Game engines. My God, what happened with the pricing at GDC? I like talking to one of my student groups, it's like, yeah, you can't really justify making an engine anymore, right? Because this stuff is now all so freaking cheap that your value that you add by having something you've made and customized is now so small that you shouldn't really focus on making a game engine from scratch. Certainly, you make a game engine to learn, but you don't make a game engine to use. Right? You think of it like carpentry. Right? When you're a carpenter, you make a chair. If you want to fit out a house of chairs, you go to IKEA and you buy those chairs. Right? You don't handcraft every chair in the culture house. Right? That would be ridiculous and unnecessary. Right? If you have a special commission for like a really elaborate chair, yeah, then maybe you do some really hard crafting work. But game engines, it's now a no-brainer. You use one of, well, at least these three are now all kind of doing the whole, yeah, just use this for free, and you know, if you make money, then we'll get a little bit back at some point from you, but that's cool, just go for it. So as a game developer, that changes the way you think about the balance between, do I make this myself, do I use an engine? And I agree with Amy. Amy? Sorry. Was it Amy? Adria, sorry. With Adria, I agree, picking a tool, so you picked Unity, excellent choice, it's a great engine. If you'd picked, well, Unreal has improved a lot in the last year, right? A year ago, it was not really a very good choice. Now it is a very good choice. And this is what I talk about with my students also, is this idea of knowledge. And what is the half-life of your knowledge, right? So a student comes to me and says, should I use Unreal or Unity? And I say, well, you know, it's been a while since I've looked at those. Maybe, you know, about 6 months. I don't know anymore. Right? My knowledge about which is the right choice has been superseded by reality changing. Right? So you have to then do a new evaluation. I had this 10 years ago when I first started teaching games, where I had the students, I had an intern come over from Germany and do a review of the game engines. And we wrote it up as a white paper and published it. And the next year, when I went to have a look at the game engines, I found that some of those engines had specifically changed things that I wrote about. And I actually, I actually got hold of one of the developers and said, okay, so you guys made this, like, why did you do that? And he said, well, I did read this paper that was talking about our game engine and why it wasn't chosen, so we thought we'd fix that. All right? Now that process of if you publish and make large statements that are noticeable to people about what's the failing in their system, by the time you get round to having a look at it again, they may have fixed all of those, right? Because they do search the web for stuff about them and how they can improve. So any evaluation you make of which engine to choose, you have to make it kind of right now, right? You don't go like, oh yeah, no, that one used to be slow, so we don't going to use that, right? Because it might have completely changed. When I was working commercially, we had this with Flash, where we had been using trigonometry table lookup, right? Because that was faster than actually running trig, right? Rather than doing arc sine and cosine and sine, you just pre-calculate and make a little lookup table and then go and look at the lookup table. Then they went from 8 to 9 and the performance completely reversed. Lookup was now much slower than running the math functions. And so all those little dirty tricks we'd worked out for how to optimize our game, Flash games in that engine, throw it all away, right? And that's happening more and more, right? You guys, great, exciting time to have all these wonderful engines, but they're changing so fast, right? That value of, oh yeah, I've learned this thing, but that thing keeps changing, it's moving, it's developing. C++11 completely changed C++. Our fingers had the same problem, you know, Microsoft is like, oh yeah, DirectX, yeah, the whole, like, you know, you were teaching in your software engineering course, not DirectX, they moved back to DirectX from XNA, right? So I was actually, it's surprising, I was at the GDC talk where they announced XNA as their combination thing, where everyone thought they were going to announce the Xbox stuff. And, you know, they merged it, and then, you know, at some point they just decided, no, we're going to kill that. Right? And all your learning, out the window. That happens all the time. Your only advantage as a developer is to stay agile, right? To be able to change and to update and to reevaluate. So I'm like the second half of the bit of my talk is about the development process, right? So those are all kind of user technologies, right? Now this talk was technologies and the influence on kind of game technologies and game development, right? Because, you know, this is a development crowd, hopefully, mostly. Concept development. How do you create your concept? Well, what kind of technologies? You know, concept art is still concept art, right? There's still tablets and people are still drawing on the Wacom tablets and drawing their art. Well, you know, one of the technologies that is coming along is this idea of automated content creation. And so in the trucks there, the green trucks were made by a modeler, and all the other trucks were made by the system working out what were the components of a truck and working out how it could recombine those components to make other trucks. Right? So you can look around and you can see various types of diggers with various types of attachments and kind of all the massive variety. Right? And this is an automated tool. Right? And what you do, and I've seen this in various other places, is you create some models yourself. And then you let it iterate over what you think is exciting. And so if you have a look here, this was another one on a recent paper on looking at kind of monster generation. So they had a modeler build those models up the top, right? Quickly do some concept monsters. And then it's fairly blurry, but in here, you can see they've got like concepts with 2 heads and like with various arms put on bodies and like big heads on bodies and multiple. They have it automatically generate this. And then what you can do is you can click on the ones that you like and put those into the next pool. And then let it iterate on those. So instead of you going to an artist and saying, hey, artist, generate some interesting monsters for me, what you do is you get an artist to do a bunch of models, like 5 or 6 models of different types. And then you let the computer iterate on it while you watch, and you just keep selecting ones that you think look interesting. and it evolves the models into ones that look the way you want to as a developer. You don't even need the art ability at that point, because you've got enough assets from the kinds of models you make. This is very different concept development work. This is no longer the process where you ask an artist to do a whole bunch of concept work and take a lot of time to do that. It's a different part of the process. Right? It doesn't, certainly it doesn't completely replace concept artists in any sense, right? Because concept artists, oh, bother. I do actually have power supply in here. It has about sort of a minute before it then dies. So, oh, not that one. One of these. 28, 27, 26. Do we actually have, there we go. So it doesn't replace concept artists, but it can change your process. And so got there in time. Move my mouse in the right place. So this approach of how do I generate concepts? Technology is coming into that area and allowing us to do different ways of generating content. So if you're having the computer generate a bunch of new art assets, where is the value? What is your value proposition? What are you adding to this? Right? There's also a whole bunch of weird questions around who owns the copyright of those new models. Right? Because is it the artist that created the models, or you as the person who is running the program that recombined those models in new derivative ways? Can you just buy some models and then, you know, buy 3 models and recombine them in massive numbers of ways, and then you have all of these models? Right? There's a whole bunch of really interesting questions. It also changes your team dynamic, right? Because the technology becomes kind of part of the process. You as an observer of the creativity can do the choices. Right? Before, you needed a creative person to create all those things. Now, the computer can actually do quite a lot of that creative recombination work. And so I, as a programmer who, a programmer who doesn't have a lot of art experience or ability, can be choosing between models rather than having to develop models. So that's a different way of thinking about your creative process. Development process. 3D scanning. And that's everything from like Fuel 3D, that's €1,000. You've got Structure.io, which you can put on your iPhone. There are new sensors which they're looking at putting into the cell phone camera, which uses the optical properties to do microstructure 3D. Right? So it actually doesn't use a structured lighting approach, it looks at the wavelengths of light bouncing off an object to work out how far away the object is. Right? Which is kind of weird. But once you've got 3D scanning, you can change some of your process. Right? You change away from saying, okay, we need modelers to generate a massive number of 3D models to, well, you know, I just go down to the local pawn shop, op shop, the local kind of second-hand store, and if I want a bunch of cups, I'll just buy a bunch of cups and scan them. Right? I don't need someone to actually model those, because any real-world object, put it in the scanner, get a perfect textured 3D model. And with some of the technology coming out around analysing structure, they can do automatic rigging of some structures. Right? They can work out how you might rig and animate a model. Right? So one of the ways they do this is you grab a real object, you put it in there, you scan it, you then move the bits that are movable, scan it again, it then works out the interpolation between those two positions and go, so the bones must be there, there, and there because it was able to move that movement. So now you've got a fully rigged 3D model from just going and buying the little robot down at the hardware store. Didn't have to pay anybody for any actual modelling rigging. That changes your team again. Right? It means you have to be better at finding real-world objects and utilising them, rather than just creating everything from scratch. That use of real models, the use of textures which are textured onto things, those change development. right? And that technology is coming, right? You can buy those 3D scanners, you can start doing this, this is kind of now, and its effect will be significant in teams, right? As those balances change. Ray tracing, okay, so I'm coming back to this one, because ray tracing is a nice output technology, it makes your game look different to other people's games. As a developer, how many of you are learning constructive solid geometry as part of your graphics courses? I've got one person teaching constructive solid geometry. Constructive solid geometry is the opposite of this mesh, like the meshes, right? So the meshes, you influence the surface by like pulling vertices and pulling them out, and you move vertices around and you make triangles. Constructive solid geometry, you have mathematical forms, and you do algorithmic combinations, like unions and intersections, of those mathematical forms to create mathematical shapes. You don't touch vertices. There are no vertices. Right? And the process is completely different to modeling. Right? And instead of having your mental model of, I have a mesh, which is the shell around the outside of my object is actually, a solid object. I can cut into it, and there's stuff on the inside that has physical properties. Right? I don't have to recreate the surface mesh anymore. It is actually kind of has a definition. That's a very different way of thinking about how you build your models, how you change your models. One of my colleagues at Otago, he did his PhD on volume conserving models. Right? So what he did is he was looking at if you have a clay model and you push on one side of it. Right? Currently, what happens with your meshes is you grab a vertex and you push it in. There's no volume inside, so it just goes in. Right? You just have complete control. What he did is he wrote those algorithms around when you push this in, it conserves the volume inside the shape, so the other side has to expand to cope with the fact that you've compressed this side. And actually he then used that technology, which he called swirling sweepers, which to kind of deal with this volume conservation to do clouds. Right? Because clouds have a volume and you kind of blow wind at them and the volume gets conserved. And so he actually now works at Pixar and did the clouds in the movie Up. Right? So Pixar are using that technology, and it's his technology that he developed. Too slow for real-time games, sort of, 6 years ago, but now, now we've got that power. And so this change of having real properties, right? All of that kind of faking tricks, as you said, VR, you get close to things, you can see all the tricks. With ray tracing, you have to define the physical properties of the objects that the rays are hitting. You can't do the same kind of tricks you did with polygons. Right? There'll be a period, certainly for the next 3 or 4 years, where we'll be ray tracing polygon meshes, right? Because the workflow won't change fast enough. But there'll be a move away from polygons to this mathematical description of objects and shapes. That's going to change the process a lot, and you're going to have to relearn what it is to do modeling. Right? That's a technology change. And that's this, yes. What happens to my pipeline? Yeah. Do I, as Mary said, do I need to smoke a different pipe now? Because the pipeline's completely changing. And tricks versus real is a big change. AI game testing. Okay, so I'm doing this with a few of my bachelor projects now, and I see that so Stanford have this game testing, sort of a generic game playing experiment. And what it is basically AIs compete over a new set of game rules. Right? So they create a new game, and they say, right, you write your generic game-playing AI, we'll give you an unknown game, and you'll compete on that unknown game. So these AIs don't know how the world, they just know they can read the representation of the game, and then they have to play it. Right? So at the moment, that's on board games. They're doing more and more work on first-person shooters. of having robots play your games. Now, playtesting. Right? We say, playtest early, playtest often. Get your end users involved, get them playing. It's expensive to do that. And a lot of what they find is pretty obvious stuff you already should know. So what you do is you get your AI to play your game every single night. And in fact, given the power now, you can actually have it playing per build, right? You guys have this kind of constant compiling metaphor now, right? So you run some code, and occasionally it will work and compile, and it will show you that, yes, you've now got working code. It could then get the AIs to play your game while you're developing the next feature, and show you the balance between red versus blue, who wins, how many times they use a particular weapon. Like all of those kind of playtesting stats you want can be done while you're developing in real time by these kind of AI systems. Doesn't remove the need for human testers, but it means that they test those things that are interesting to test, rather than, oh, this menu broke, or, oh, that gun's too strong, right? You just played the AIs against each other, you could see that that gun was too strong, right? So getting quality testing is where this kind of, one of the areas that AI is going to change your development process, because you're just going to strap this on as a tool. So, testing constantly, improving game balance, understanding how to represent your game so that the AIs can play it effectively. Right? That's going to be one of the changes in understanding. And it creates more complexity. The last area, maintenance. All of this amount of big data we're getting out of games now. Right? If you guys aren't logging all your player experiences and putting them into a database so you can see where the bugs are, who's doing what, how to improve my game, who's being blocked at what level, then you're kind of missing out on the massive maintenance end of the processing. And as a developer, it means you have to understand your game better, right? And you'll get better understanding your game. You have to understand what the numbers mean that you get back from all of that tracking. And it kind of also allows you to share with your players the development process of improving your game. Right? And you see the streamers love this kind of stuff, right? Because it allows them to point at, hey, look, this is what's happening in the game. That engagement is part of that maintenance. You don't think of a game as being released and then, gone. Sorry. But if you're looking to get money and keep getting money off it, you have to keep it alive and going, right? And respond to those challenges. And so the last thing I was going to say is change, right? There is going to be significant change in process. Right? There already kind of has been. We actually have currently lots of people saying just use Unity. But again, the process will change. Technology will remove some of those simple jobs. Right? If you're doing a very, very simple job, you're probably more at risk than anyone else of your job disappearing in game development. Less time doing mundane work, more time being challenged as a developer and a designer, because we're removing those simple tasks, which only leaves the hard tasks, right? Now, I remember I was talking to a Russian in his 70s, he was a Russian lecturer, and he said that during the communist years, when he was in his 30s, they made him go and work at a pea packing factory. He would take tins of peas and put them in boxes, 1 day a week, right? Because you couldn't have these airy-fairy academics not producing something for the population. And he said that was his most productive time of the week, was spending 8 hours putting tins into boxes, because he didn't have any distractions, and he could think. With removing the mundane jobs of game development, we just leave the hard jobs. And so now you have to strategically choose to step back. Rather than kind of being forced to, because I just have to do this mundane task, you have to choose to step back and reflect. Right? Just like you were talking about, the deadlines, the freedom is too much. That choice of saying, okay, I'm no longer given these restrictions, how do I recreate those restrictions? that's the kind of biggest lesson around this tech, is we're going to have to make some hard choices, and it's going to be more complex. But, you know, we're going to get more done. And the last thing is, you know, VR, for me, VR is big this Christmas. Right? So this Christmas, I should expect to see some content, actually people buying Christmas presents for 14-year-olds that are VR headsets. Okay, so any questions? No. Okay, well, thank you very much. Oh, okay, go on.
In terms of VR.
Yes.
What kind of numbers do you foresee?
What kind of numbers? Okay, so.
If you think like the game developers, you have to think about how many licenses.
Yeah. What is the market section that you're able to develop for? Okay, so I would see that the Christmas this year, I would expect. I'm going to pick around the kind of 200,000 to 500,000 sales, right, of VR headsets. That's where I would pick that they will do this Christmas, because they won't all be released and there won't be a massive content hit as you're suggesting, right? But I'm expecting in the few hundreds of thousands of units sold. I would expect that to ramp up as the Morpheus comes through in January, and then to be moving into the sort of by December next year, so December 16, I'd expect your install base to be over 1 million and probably heading towards 2 million would be where I would, that's my current prediction. I could be massively wrong, it could go 10 million this Christmas. I don't think it will, but what are your thoughts, Andreas? You're probably closer to this than I am.
Wouldn't be any better.
You'd also roll the dice, but...
DK1 has sold somewhere between 50,000 and 100,000 pounds already, and that's development 1.
Yeah.
So there's certainly a big market.
There is a big market, so I wouldn't be surprised to hit that few 100,000 sales for that Christmas period, right? Whether they'll go beyond just those early adopters and actually hit massive, because, you know, for the DK1 and DK2, like everybody waiting for like VR stuff kind of did jump in there, right? So you're actually probably hitting a fairly large portion of the early adopters for VR was that few hundred, like about under 100,000 odd people. So that's why I'm kind of doubling to tripling that to say, well, there's probably consumers who are keen but aren't willing to sign up to be a developer. Well, sign up. Click the box that says, yes, honestly, I'm a developer. So so in terms of install base, yeah, a few 100,000. It's going to be hard to make profit from those. It will be relatively easy at this stage to get visibility by making a good game in that area. And if you then have visibility, you would look at making profit in the next year once the platform gets large enough, right? So, yeah, but you could put all your eggs in a basket and bet on it being bigger than that. And some people will, and there'll be some people who it works for, and other people who it doesn't. So yeah, it's still, you know, I think a lot of people will buy them, and I think the next year they'll be like completely massive. That said, I'm predicting by June next year, you'll have some of the first newspaper articles of, you know, the people getting lost in VR and not coming out and having emotional and psychological problems, and you probably have the first death caused by VR in summer next year, or the death attributed to VR gaming. And so that will then affect the Christmas sales the year after. But, yeah. Okay.
Focused on first, fusion VR next year. Is it that we have to jump into developing VR games? On the second point, you focus on when you said technology, you focus on hardware. But also, there is also another part of technology that is software part, and there's research going on into the algorithms.
Well, okay. So yeah. Okay. So yeah, I'll answer those two if we've still got some time. Tell me when to stop. Okay. So the first one, no, you don't have to go into VR games. Right? As our very astute question was, you know, how many people can you sell this shit to? I mean, that's, you know, where's the money, right? Show me the money and then I might change my decisions. And, you know, when you compare what Destiny has 16 million registered users, WoW 10 million, yeah, we're not talking those numbers, right? So no, RuneScape and Candy Crush, and you know, those are big numbers, right? So those, yeah, completely different. So I wouldn't say you all have to go into it. It's worth thinking about, and if you've got the ability to take the risk, then you know it's a risk you could choose to take, but you need to go into it eyes open. The second one I focused on, well, the AI stuff wasn't about AI hardware, it's about AI software. The big data analysis was about software. The ray tracing is software. So most of actually what I was talking about there was software, but enabled by hardware, right? Now the interesting thing there, you talk about like analysis and algorithms. I've seen, and the trend I see, is that the hardware improvements have been outpacing the algorithmic improvements for the last decade or so, right? So we're like, for physics simulations, they've got to the point where, you know, you can do massively complex algorithmic models, or you can brute force it, right? You can just build little, you know, point masses with springs attached and just say, you know, I'm just going to brute force 100 million particles, which are all spring masses. And, you know, I'm not going to do any kind of amazing mathematical models of this. I'm just going to brute force it with the hardware. And the brute forcing with the hardware is now beating the clever algorithms. So my prediction is those clever algorithms help you understand from an analytical point of view what's going on. But in terms of getting results, simple and just a huge amount of it is currently winning. And I think it probably will keep winning for a bit, for a while yet. Right? We will hit hardware limits, and we are starting to hit like physical hardware limits. But we're there, yeah. At the moment, the algorithms aren't keeping pace with the hardware. The hardware is just outstripping performance-wise. Okay, yep. Go. Yeah, last question. Okay.
Me?
Yeah.
Well, just because I remember we had this last time, we had these predictions, we talked about the future, some maybe some far closer, that's fair enough, but we talk about game developers and other, you know, us people who work in the academics who teach how to make games. Is there anything on these trends you think are going to affect how we teach, what we actually teach the new game developers? Because the last time we talked about it, I don't think anything has changed actually
how we teach the...
No, not just how we teach, I mean the stuff we teach. Maybe,
the things we teach.
Yeah. Anything that's going to affect the ray tracing, maybe is...
I think, well, okay, personally, I think that we're going to have this discussion tomorrow, okay, partly. I think there is more change coming to universities than universities are ready for. Okay? And I believe the whole flipped classrooms, MOOC, student-driven learning, knowledge. Universities still think they're about knowledge, and that's, how do you compete with Wikipedia, right? They're free, right? There's no economy in knowledge, right? Knowledge is free, so you can't build your economy on it. So I think universities being, oh yeah, we're a repository of knowledge. Yeah, that's a waste of time, right? So universities just haven't worked that out yet, that their model for what they are is broken. How does that change the way we teach? Well, I think it has some massive, massive challenges. I think, personally, I'm moving towards teaching inquisition rather than teaching knowledge. So I think you should be teaching around how to ask good questions. How fast you are, like, you know, how good are you at asking a good Stack Overflow question that gets you good answers quickly, right? How quick are you to find the API call that you need? Right? I don't care if you know it, right? Knowing it's relevant. How good are you at finding the thing you need, not knowing the thing you need? So basically, any exam that tests your knowledge of something, I figure is irrelevant, right? You shouldn't be sitting knowledge-based tests. Those are a complete mismatch between reality and academia. But, you know, we're a long way from saying, oh, no more knowledge-based exams, right? Yeah, universities aren't there yet. But that big changes should come. They'll just take a very long time for universities to change.
Thanks.